Hello, my name is Peter and I'm the lead data scientist at Morrisons. We are a leading UK supermarket. We've got 500 stores around England, Wales and Scotland. And I hope that some of the insights I've got to share with you today are going to be useful and thought-provoking. I'm going to set out in this presentation some background information around relational databases. And I'm going to talk to you a little bit about why relational databases need a reboot. I'm not going to say that they're redundant. What I am going to say is that there is a better way in some cases, and I'll share with you some really great examples of how graph databases can really supercharge your analytics. When I'm preparing for a session like today, I often think back to a colleague of mine that I worked with a few years ago. And he would start out any group session where there were more than sort of 3 or 4 people, and he'd take a selfie with his phone. He'd stand with the group, turn around, and he'd get an image. And the reason he did that was he wanted to be able to look back through his photo roll to see the people he was with, and that reminded him of the things he was talking about and the reason he was there. Now, when I first came across this, I was always a little bit unsure, but it dawned on me that he was a very visual person. And the reason he was taking that selfie was because that was the way he best processed information. And I'll come back to that a little bit later on in the presentation. And it really is true to say that images can tell a story of 1,000 words. So if I pop up this image, the question is, what's the story? Well, the story is of an individual, that's me, a 9-year-old individual who was given a reconditioned Sharp computer. And that's the one you can see on the screen today. Now, back in the late 80s, it was, in its time, quite a good machine, but it only had 32 kilobytes of memory. Now, in this day and age, in the 2020s, that can seem almost ridiculous that we even had computers with that little amount of memory. But this machine, not only did it change my life, part of the reason I'm with you today is because I developed a passion for coding at a very, very early age. So not only did it change my life, but it gave me some really well-grained principles that I've used throughout my career as a data scientist. And having such little memory in a machine like this really led me to think about keeping track of as little information as I could. When you haven't got a huge amount of storage space, you don't want to write down things any more often than you really need to. And the principles that I learned when coding with a machine like this have, like I say, they've stuck with me. And I'll come back to what has prompted me to kind of change my thinking in recent years. Now, here's another image, and it's an image of an individual called Edgar. And for those of you who have studied any kind of database theory, database architecture, you'll be very familiar with this man's work. Back in the 1970s, he was working for IBM, and he set out a principle for storing information on a computerized system. And he was effectively a very influential paper that set out, as it says here, a relational model for data for large shared data banks. Now, Codd's legacy is phenomenal. He's one of these individuals that has silently changed the face of technology over many, many years. He invented the theory that we use in a relational database. And I'm just going to spend a little bit of time just thinking about some of the principles that we use in a relational database, so that later on in the talk, we can start to think about where they actually could be improved in this day and age. Now, one of the things that you will find if you read this paper, you'll find that there are a number of things in the paper that are as true today as they were back in the 1970s. But you'll also be surprised to find that there are things in there that now have dated, some concepts in that paper that really need to be rethought. And we'll get into what they are and why they're important a little bit later on in the talk. Now, a relational database is effectively a collection of relations. And you might say, well, what is a relation? It's a concept that we all intuitively understand when we're using a relational database, but how often have you sat back and really thought about what a relation is? Now, I'm not going to dwell too much on the mathematical definition. I think it's easier to show you an example on the screen. So if we have rows and columns in a data set, we might say that the column is an attribute. Now, an attribute is something like a date of birth or an address, or any other piece of information that we might want to record about something. So let's say, for example, that this is a data set about customers. An attribute would be that name and address or the date of birth that I've just mentioned. Equally, the tuple. And remember that tuple is just a formal word that refers to a row. The tuple is information about one thing. So that might be about a specific customer. And the relation is effectively that group of information. So the relation is the mathematical basis for storing some information about something. And for many, many years, all the way through university and then through using relational databases at work, I made quite a big mistake, actually. If I look back now, it genuinely feels to me that there was a mistake in my understanding and my thinking. I used to think that relational databases were about relationships. But in actual fact, when you start to get underneath the detail, a relational database is nothing more than a database of relations. And remember that that relation is just a mathematical and logical construct. So let's think now about some real world data. So here's an example of some data that I might be given in my day job as leading data science at Morrisons. There's a couple of things that aren't quite right about this data. First of all, I'm not entirely sure if this is the final version of the spreadsheet. The title of the sheet is final version 2. But maybe there's a version 3 lurking somewhere, or maybe there's even a final version. Who knows? Once you get beyond the naming, though, there are still a couple of things that aren't quite right about this data. The first is that there is some formatting on the sheet. Formatting is great. It helps us make our spreadsheets look attractive to the reader, but they can be quite difficult. It can create some difficulties in processing that information from a data science perspective. The other thing is linked to the presentation, it's linked to the formatting, but we have some merged cells in this data. Now, merged cells really are quite difficult to work with. I think when I've referred to them before in previous talks, I've called them the enemy of insight, because if we're going to process this data set, we need to deal with the merged cells. Now, for anybody that's done any work in database architecture, you'll be very familiar with the concept of normalization. But if you've not thought too much about normalization, maybe you've not come across it before, normalization is a set of rules that Edgar set down for keeping track of our data in a very specific way that gave a number of benefits for database management. So the first thing we would do with data like this is we would take it from this form and we would put it into what we call first normal form. Now, I'm not aiming to give you a lecture in database normalization here. I'm sure other people would do a far better job than I can. But we're talking about normalization because it really helps me reinforce a point later on in the presentation. So once we have data in this normal form, this first normal form, what we've actually done is we've decomposed those merged cells. We've effectively dealt with the merged cells, and we've done that by creating now a relation for customers and a relation for products and purchases. We might want to think about that as a transactional relation. Now, we can do some other things with this data. The eagle-eyed amongst you will recognize that the manufacturing information in this transaction table is entirely dependent on the product ID. Now, in this example, that's true. In the real world, it's often not that easy. But in this example, the manufacturing information is just functionally dependent on the product ID. And therefore, if we are following the rules of normalization, we would put the data into second normal form by now taking the manufacturing information away from the transactional information. And again, what we do is we now create a new relation that is able to relate the product ID to the manufacturing ID in the way that we've done here. Now, there's a number of other steps that we would do in normalization, and once we've done all of those things, we might find ourselves in third normal form, which is typically the form that we would use to build our production databases. What we have here is we have a customer, we have a product, and then we have a transaction relation that links our customer buying many products. And this, I'm sure, will be very familiar to many people that have studied database architecture or have even just simply built a database in a relational database package. Now, you might ask, why do we do all these things? I know I've got a number of people in my data science team who haven't studied this in great detail, but just implicitly know how to do it. And often the conversation we have around the office is, well, why do we care too much about normalizing our data? Well, normalizing our data helps reduce duplication. And really critically, it helps us stop writing down things that we don't need to. So if you go back to that 9-year-old individual that I talked about at the beginning of the presentation, you'll realize that one of the reasons that this process was thought through initially in the 1970s was it was a fantastic way to make sure that we weren't writing down more information than we needed to. The whole idea of normalizing the data into different relations or tables as we would know them in production, whole idea behind that is that you only have to write a piece of information down once. And the reason we did that was because we had limitations on our storage. And it's only in recent years that's become clear to me, that the way that relational databases evolved was partly to do with the technical limitations of the processing hardware that we had available. So there's a couple of other things that we get from normalizing our data. We can reduce our data anomalies. The fact that we're only writing things down once means that it's much easier to update that information in the future. We're not having to find all the multiple copies of something in order to update those multiple copies. Referential integrity is all about making sure that if you're going to write something down, you've got some context about it. And overall, this simplifies our data management. And at no point have I talked about analytics. So what does normalizing our data do for analytics? Well, this slide is intentionally blank because this is the point at which relational databases start to break down. I'm not going to sit in front of you today and start to argue that there is no place in the world for relational databases. Far from it. Relational databases are an essential part of our technology architecture. But if we want to do some really meaningful analytics, what we need to do is rethink the model, rethink how we can get real value from the process that we go through in deriving those analytics. So let's just remember for a second that relational databases are not about relationships. They are a collection of relations, and we talked about that earlier on. With a relational database, where I've got my tables for customer and product, I can do some really, really great things. So in my customer data, I can spend time thinking about how many customers I've got. I can tell you some really interesting things about their ages and the distribution of ages. And I can probably tell you that the average age of our customers is about 38. I can probably tell you that about 50% of them are male. So I can do what we call aggregate queries on that table because the data is in a nice format. Similarly with products, I can do a lot of work counting how many products we've got, what categories are they in. And I can even do some great work looking at which customer buys which product in a single transaction. But as soon as I now want to look at what customers bought with something else over a longer period of time, things start to break down. Now, throughout my career, I've often been asked questions about things that are really, really easy to answer. And at the same time, I get asked questions from C-level executives where they think the question is really easy, but in fact, it's really quite hard to answer. And throughout my career, I've often tried to understand what is it about the easy questions that makes it easy to answer, and what is it about the hard questions that makes those really hard to answer. And what I've realized is that analysis is really easy if the data you have is in the right form. So if the question is asked of you in a way that fits your data model, and what I mean by that is it absolutely fits back into your relational structure. So somebody asks you a question about a customer, somebody asks you a question about a product, or even that relationship between the two, but in a very simple way. But if people start to ask you a question that doesn't fit your data model, you end up spending days, if not weeks, trying to fettle your data. Fettle, by the way, is a great Yorkshire term. If you're not familiar with it, it just means to put in good order. But you end up having to fettle your data into such a way as to be able to answer the question. And actually what you're doing is you're changing the data model. So what happens if we're really interested in the connections between things? So now though, people are asking us questions about how things are related, not about the things themselves. So now it's not just about how much did a customer buy or how many products have we got. The questions are now more around, if a customer has bought this, what do they then go on to buy 6 weeks in the future? Now, a really good example of that is nappies. Nappies are a really, really important product to supermarkets, because not only do they signal that a customer is going through a life change, they're also a great opportunity to disrupt the existing behavior of a customer. Is that they might be going to a specialist chemist or drugstore, they might be going to another retailer to buy those specialist baby items. As a supermarket, if we can offer great value and great choice and a great range, we've got a real great opportunity to attract that customer to come and shop with us. Now, the way to find those products is to do some advanced analytics. But actually, the way in which we write down source data based on transactions through our tills is not the best way to go and find the kind of insight that our marketing colleagues or our operational colleagues really need to know. And I'm going to spend the remainder of this talk now talking about how graph databases actually give you that opportunity, how they give you the opportunity to not only see things visually. So going back to my ex-colleague that I mentioned right at the beginning, how can we give you insight that's in a form that he can understand straight out of the box? So I've got an example here. It's just one store on one day. We can use graph databases to analyze far more than that, but sometimes it gets a little bit tricky to actually show it you in any detail. But what we've got here is a snapshot of one store and 1 day's worth of transactional information. And what we're really interested in here is anybody that's bought a product in what we might call our food to go category. Now, food to go is all the things that you might just pop in and buy whilst you're out and about doing other things. So we have a meal deal, buy a sandwich, a drink, and a snack. We also have fantastic hot food counters in Morrisons where you can come in and you can buy hot food. Like ready-made chicken or sausages or chips or things of those of that nature. Now, without me giving a huge amount more context, this diagram is already giving you a huge amount of information. It's giving you a sense that we might have 3 or maybe 4 different types of customers. And I don't need to spend hours and hours and hours showing you data tables or pie charts or graphs of other forms. The graph database, the graph analytics layer, gives you that straight out of the box. So immediately we can see what's going on. We have a set of customers that are coming to buy the meal deal. We have a set of customers that are buying hot food, and we have a set of customers that are buying pre-packed lines. Now, if we've just launched, as we did a few weeks ago, a summer range of picnic items, we might be quite interested in who's buying those lines. Are they trading in the way that we thought they might do when we launched the range? Are they being bought by people who are otherwise coming in for their regular lunchtime food, or are they being bought by customers who are making a special effort to come today to buy some things they might take out on a picnic to eat days later? All of these kind of questions we can start to answer now the data is in this form. And I think one of the things, really key things to stress here, is that a graph database layer sits on top of your existing architecture. So the intention here is not to replace our existing relational databases or even our existing, NoSQL instances like Mongo or whatever. This is very much a way of putting an analytical layer on top of our existing data architecture. And the reason we're doing that is to create an environment where we can generate insight much more quickly and in a much more meaningful way. Now that we have the data in this form, not only have we been able to visually represent this information, but we can start to do some network analysis on the data in this form to learn and interpret some really, really interesting things. So one of the fascinating things about analyzing the community, so this is the purple area that sit with the sandwich meal deal, is that on the edge of it, on the far right-hand side of the diagram, are all our vegan products that sit within that sandwich meal deal. So these are all your wraps that have falafel in. We have a number of great salads that are vegan salads. The customers that are buying those products are about as far away as you can get from what we're referring to here as pre-pack lines. And that makes a lot of sense because a lot of those pre-pack lines tend to be meat related. So those are your sausage rolls, those are your pork pies, products of that nature. So having the data in this form without a huge amount of processing or a huge amount of extra work, we've immediately learned something really interesting that is now telling us how our customers are shopping. The fact that we've found that vegan customers aren't buying sausage rolls isn't a massive surprise, but it's a real reassurance that by looking at the data in this way, the other things, the unknown unknowns that we start to trip over that we didn't already know or that we didn't expect, it tells us that we can trust those insights. So often finding from an insights perspective, something that's glaringly obvious is a really important step in the process, because it means if you find something else along that journey, you can really trust what you're finding out. Now, if we zoom into the middle of the diagram I've just shown you, you get to see some specific products. There's a couple of products on there that really do knit those communities together. So if I just jump back slightly, what we're showing you here now is the center of this diagram. It's almost the point where the green and the purple are starting to overlap. And they're starting to overlap because customers are buying a number of key products at the same time. And so the family Bramley apple pie that I'm highlighting there, that's the in-store produced version that we have in the UK. If there's one thing you take away from this presentation, it's find a Morrisons, go find that product and see what you think. You won't be disappointed. It's a really important product for customers because it's connecting together the baskets of people who are coming in to buy their lunch, their sandwich meal deals, and it's connecting together all those people who are coming in for picnic items or for their slightly longer horizon products that would be pre-packed. We can use that insight to really understand how our shoppers shop, and we can start to use that to build the foundations of building an experience for our customers that really gives those customers a fantastic experience, like I say. There's a whole range of other examples that I've got to share in the last few minutes. This one here is looking at a supply chain example where in Morrisons we are what's called a vertically integrated business, and that means that we actually are involved in the supply chain throughout a much larger part of our overall supply chain than some of the other supermarkets in the UK. So, for example, we have a number of farms that are operated for Morrisons, and we have a number of abattoirs and meat processing plants, and so we make a very large percentage of the food that we sell in our stores. So it's really important that we start to understand the flow of product from farm through the processing manufacturing lines out into store. And I'm not going to go into great detail about what this is showing us, but again, having data in this form starts to enable us to see that there is an element of flow through this network. And the way in which the weights on the edges, so effectively that means the width of the arrows, the way in which those weights have been set up gives us an idea of the volume that's flowing through these points. And we can clearly see that we've got beef farmer B is sending the most stock through to stores 5 and 6. And so if we ever start to experience some disruption either at the store or the farmer's end, we can start to use data in this format to try and rewire our supply chain network to make sure that we can protect the availability for our customers. And the specific example is really, really interesting, and don't think that graph analytics is only for customers who bought X can buy Y. There are a huge number of operational examples of where looking at data through a graph analytics layer through using a graph database, a huge number of examples where that gives you a whole load of extra operational information that you can use in real time to understand how to make those subtle changes that you need in order to respond to changing market conditions. Now, the final slide that I have is effectively just a helicopter view. It's another example of our supply chain. And again, without giving you any context to what this is showing, you can start to build a picture in your own mind, because it's a very visual format of maybe a hub and spoke model in how we distribute products. And that's true. But at the bottom of the diagram, there's just a little bit of complexity. There's no more graceful mathematical way of saying it's just a bit messy. And actually, I would argue that in great supply chains, what you have is your resilience is created by having messy connections. And the reason that's true is that those messy connections give you lots of different routes to get products from A to B. So arguably, you want to move a little bit away from the hub and spoke model to having something where you're able to respond in near real time in order to get your products in the right place at the right time. Those are the examples I had to share with you today. And I think if I was to recap on what we've talked about, it's that the relational database certainly isn't dead. It has a huge part to play in the future, but it only gets you so far in understanding how to do great analytics and how to prepare data in a fantastic way for machine learning. In order to break beyond the limitations that relational database gives you, you have to think about things in different ways. And that different way could be the use of a graph database, and could be the way I've shown today. So graph databases, I think, are a really exciting next generation for analytics and machine learning. How you build those into your architecture, I think, is a key question that you should be asking yourself. And if you do that, it will certainly give you the opportunity to make those relatively hard questions much more easy, because the data model you've got becomes much more responsive and flexible. So if you go down this route, there should be fewer times where you're sat there scratching your head wondering how to answer a question, because by its very nature, implicitly, graph databases do give you that opportunity to kind of rewire your data model on the fly in order to answer the right kind of questions at the right time. Thank you very much for listening today. I hope you found some of what I've said interesting. If you've got any feedback, please, if you've got any feedback, please find me through LinkedIn or through the conference itself. I'd be very happy to answer any questions you might have. Thank you very much.